Welcome everyone in lecture number 20. In this video lecture, I will tell you very important concept of Laplace transform, which is convolution theorem. This theorem actually find the Laplace inverse of product of two functions. Whenever it is difficult to use method of partial fractions or Heaviside expansion theorem or any other method, we can adopt this method. Okay, so let me state this theorem first. So the theorem says that if Laplace inverse of Fp is equal to Ft and Laplace inverse of Gp is equal to Gt, then Laplace inverse of Fp into Gp will be integral 0 to t fu. Here t will be replaced by u into gt minus u du. We also denote this expression by f star g, this whole expression. Okay, so here you are given two functions fp and gp. You have to identify fp and gp in the given question, and after identifying these two functions, take the Laplace inverse of both to get ft and gt, and then find the Laplace inverse of product of these two by using this formula. तो इस फॉर्मूले में आपको ये ध्यान रखना है कि आपको जीपी और एफपी के सिलेक्शन में मींस आपको किस फंक्शन को जीपी लेना है, किस फंक्शन को एफपी लेना है. दिस इज अ वेरी स्मार्ट डिसीजन, बिकॉज if you choose the function gp which is such that its Laplace inverse is very difficult or some complicated function, then that function become more complicated when t is replaced by t minus u. So you have to keep in mind while the selection of these two functions that gp should be the simpler function and fp may be any other function. So gp will be that function whose Laplace inverse is not very difficult, or it is a simple function, because here we have to make this function as function of t minus u by replacing t by t minus u. So you can see that this function become more difficult. Okay, so you have to remember this point while selection of these two functions. So let me first tell you the proof of this theorem, because the proof is very important. So here we have to prove that the Laplace inverse of this product is equal to this. Whenever you have to prove that Laplace inverse of suppose fp is equal to ft, then you can also show that Laplace transform of ft is equal to fp. That will automatically imply that Laplace inverse of fp is equal to ft. So we use this trick here. We suppose this whole integration as ht as a function of t, because you will have the function of t after integrating this, you will have the function of t. So let this function is denoted by ht. So we denote this whole expression integral fu gt minus u du by ht, and we will show that, prove that Laplace transform of Laplace transform of ht is fp into gp. करेक्ट, हम ये प्रूफ कर देंगे. So let me start from ht. So Laplace transform of any function is defined as integration 0 to infinity e raised power minus pt ft dt. So here ft is ht, so I put ht here and dt. Now we substitute the value of ht here. So 0 to infinity e raised power minus pt integral 0 to t fu into gt minus u du. This is the value of ht. You see ht हमने ये माना था इस एक्सप्रेशन को, तो ht की वैल्यू हमने इधर सब्स्टिट्यूट की हुई है इस ब्रैकेट में, and this is dt. Okay, so mark this as equation number 1. Now let me draw the region of integration. Let us draw region of integration. Region of integration is obtained by marking these limits on the graph paper. So let me use another color for it. Let me take it green color for it. So this is okay. So here we have one variable is u, another variable is t. So here we have u is equal to 0. We have total 4 equations. Let me write the equations. What are the equations? For this integral, innermost integral, limit is 0 to t, means u is equal to 0, and here u is equal to t. For outer integral, these are limits for t, that is t is equal to 0 and t is equal to infinity. So one axis stands for u, another is for t. So this is u and this is t. So your equation u is equal to 0 will be here. This is whole t axis. U is equal to 0 is represented by t axis, and then u is equal to t is a straight line passing through origin. So let me take this. This is u is equal to t, and another is t is equal to 0. So this whole u axis is t is equal to 0, and another is t is equal to infinity. T is equal to infinity is the infinity is no point here. So t is equal to infinity is open here. There is no t is equal to infinity here. This is a, so t is equal to infinity is somewhere at very far away, you can imagine. So this is the region of integration is this region which is bounded by these lines. So we have this region of integration. This is the region of integration. I am drawing it with red lines. You can see here, this is a region of integration. I'm shading it with red color. And this is open, unbounded region of integration. Okay. Now, we change the order of integration. How do we change the order of integration? We by changing the order of integration means here you have double integral, and this means that you have to solve this inner integral first and then outer integral. By changing the order of integration is, first I integrate the whole, I want the limit of t here, means I want dt inside the bracket and du outside the bracket. So we simply don't replace these integrations. Means you can put 0 to infinity inside the bracket and 0 to t outside the bracket to change the order of integration. That is not the way to change the order of integration. We have to draw the region of integration first, and then आपको यहाँ पर t की लिमिट पहले चाहिए. मीन्स क्योंकि u की लिमिट है, हमें t पहले चाहिए, तो t is x horizontal axis, so we draw a line parallel to horizontal axis. It is not clear here by this color, so let me take another color for it. Let me take black color. So I draw a line strip horizontal to t axis. Okay, so this is a horizontal strip because I want the limits of t in inner bracket. Means I want to solve the integral for t first. तो हमें t की लिमिट पहले चाहिए, इसलिए हमने t एक्सिस के पैरेलल एक स्ट्रिप ड्रॉ की है. Now you see that what is the value of t at this end. At this end, the value of t is u, because this end touches this line, and at this line t is always is equal to u. So I should write here by changing the order of integration, equation 1 becomes now I have t is equal to u. Then you see what is the value here. Here t is going up to infinity because this strip is touching the line which is at infinity. So t is equal to infinity here. And then I put the value here, which is put the functions, which are the functions of t. Okay. Now they move this strip from this point up to this point to get the value of, to get the limits of u. So at this, when the strip touches this line, u will become 0. Means at this axis u is equal to 0. And when this strip go upwards, it will become a point, and the point is situated at infinity somewhere, so u is equal to infinity here. And here I put function of u and then du. This is the value of this integral, this expression, after changing the order of integration. Now what we do here is, let me write it on the next page. Now equation 1 is equivalent to u is equal to 0 to infinity fu. I just multiply by e raised power pu and e raised power minus pu. Why I am telling you? This is minus pu and here I put pu. Okay, that doesn't make any change. So here I multiply e raised power pu, e raised power minus pu, these two terms inside this. So e raised power pu will come here to make it as t minus u whenever you take minus sign common, and e raised power minus p will go with this. Okay, so this is equal to now you combine these two, this one and this one. So this is minus p, you can take common, so this will become t minus u, gt minus u dt into du. Now I suppose t minus u to be as v, so that dt is equal to dv. So now my expression becomes the limit will be whenever I put t is equal to u here, v will be 0 here, and at infinity v will be infinity, e raised power minus pv gv dv, and you can compare this with the definition of Laplace transform. This is Laplace transform of g v. So I replace this by L of gv. So this will become u is equal to 0 to infinity e raised power minus p u fu, and Laplace transform of gv is denoted by gp. So I put here gp du. So since this is a constant, you can take it outside, and the rest of the expression is again the Laplace transform of fu, which is denoted by fp. So I replace this by fp. That's all. This completes the proof that Laplace inverse of uh, Laplace transform of ht. I prove that it is equal to gp into fp. So Laplace inverse of gp into fp will be equal to ht, and this is also denoted by f star g. Okay, in my next lecture I'll discuss the problems with this theorem. Okay, thank you for listening the lecture.